At 85,000 feet above the Earth, the sky stops looking blue. It turns dark, almost black. The horizon curves slightly. The air is so thin it barely counts as atmosphere anymore. Down below, the planet moves slowly, but inside the cockpit of a long, black aircraft slicing across the sky at more than three times the speed of sound, something strange happens. Time begins to behave differently. Not literally, of course, but practically. Because when an aircraft moves this fast, the world underneath struggles to keep up. Cities pass in seconds. Entire countries slide beneath the wings before a pilot can finish a sentence. Radar stations try to lock on and fail. Missiles launch. And this was the reality of the SR-71 Blackbird, an airplane so fast, so extreme, that its pilots joked about outrunning time itself. But the strange part of the story is not how fast it flew. The strange part is why it had to exist at all. To understand that, we have to rewind to a moment when the sky became the most dangerous place on Earth. The late 1950s. The Cold War had turned the planet into a giant chessboard. Two superpowers, the United States and the Soviet Union, were locked in a silent competition of paranoia. Neither side trusted the other. Both sides feared surprise attacks. Nuclear weapons had changed everything. In this world, information became the most valuable weapon imaginable. If you knew what the other side was building, where their missiles were located, and how fast their technology was advancing, you could avoid catastrophe. If you didn't know, you were gambling with the survival of your country. The United States had one solution at first: high-altitude spy planes. Aircraft like the U-2 could fly over enemy territory and photograph military installations from extreme heights. For a while it worked. Then in 1960, a U-2 piloted by Gary Powers was shot down over the Soviet Union. The message was clear. Flying high was no longer enough. If the United States wanted to see inside the Soviet Union, it needed something new. Not just higher, faster, much faster. This is where a quiet engineer named Clarence Kelly Johnson enters the story. Johnson ran a secret division inside Lockheed called Skunk Works. Their job was simple to describe and almost impossible to achieve: build aircraft that sounded like science fiction. Johnson and his team faced a brutal set of physics problems. To survive over hostile territory, a reconnaissance plane had to avoid missiles and radar. There were only two ways to do that: hide or outrun everything. Stealth technology barely existed yet. Radar-absorbing materials were primitive. Computers were still room-sized machines. So Johnson chose the second option: speed, ridiculous speed. The target performance they proposed sounded absurd. Mach 3, more than 2,200 miles per hour. At those speeds, a new kind of problem appears. Air friction heats the aircraft so intensely that it behaves more like a rocket than an airplane. The skin temperature climbs. Above 500 degrees Fahrenheit, metal expands, fuel systems leak. Normal aviation materials start failing. To survive this environment, the SR-71 had to be built from titanium. And here's the irony: the United States barely produced titanium at the time. The Soviet Union did. So the CIA secretly purchased massive amounts of Soviet titanium through shell companies to build an aircraft designed to spy on the Soviet Union. Cold War logic had a strange sense of humor. When the SR-71 prototype finally rolled out in the early 1960s, it looked unlike anything that had ever flown. Long, sharp, black. Its shape was designed not just for aerodynamics but for managing heat and radar reflections. Even its paint served a purpose. The black coating helped radiate heat away from the aircraft during high-speed flight. But the real magic happened inside the engines. The SR-71 used a pair of Pratt & Whitney J58 engines that behaved in a way no normal jet engine does. At low speed, they functioned like conventional turbojets. But as the aircraft accelerated past Mach 2, something remarkable happened. Most of the thrust stopped coming from the engines themselves. Instead, the engine nacelles turned into giant ramjets. Air slammed into the inlets at supersonic speeds, slowed through shockwaves, and ignited with fuel in a controlled explosion of forward momentum. At Mach 3, roughly 80% of the thrust came from this ramjet effect, which means the airplane was essentially riding its own shockwaves through the sky. It wasn't just flying, it was surfing physics. But all this engineering brilliance served one simple mission: look, photograph enemy territory, then get out before anyone could stop you. A typical SR-71 mission began quietly. Takeoff required a full runway and specialized fuel called JP7, designed to remain stable at extreme temperatures. Interestingly, the aircraft leaked fuel on the ground. Constantly. This wasn't a flaw. It was intentional. The plane's titanium skin expanded dramatically during high-speed flight, sealing the fuel tanks in the air. On the ground, the gaps were slightly open, so Blackbirds often took off with partial fuel loads, met a tanker shortly after launch and refueled before heading toward hostile airspace. Then the real acceleration began. Mach 1, Mach 2, Mach 3. At those speeds, the aircraft crossed the continental United States in roughly an hour, and if enemy radar detected it, missiles would launch. Surface-to-air missiles are incredibly fast, but the SR-71 had a trick. When a missile warning appeared, pilots didn't perform violent evasive maneuvers. They didn't dive, they didn't turn, they simply pushed the throttles forward. Accelerate, that was the official procedure, because the faster the SR-71 flew, the harder it became for missiles to catch it. In its entire operational history, more than 4,000 missiles were launched at SR-71 aircraft. Not one successfully intercepted it. Think about that for a moment. Thousands of attempts, 0 kills. Speed had turned defense into offense, and that's where the strange relationship with time began to appear. Pilots often describe the sensation of watching the world blur past at an almost absurd rate. A mountain range might take seconds to cross. Whether systems the size of cities passed beneath the wings like small clouds, the aircraft moved so fast that onboard cameras could photograph hundreds of thousands of square miles in a single mission. One flight could gather intelligence that once required dozens of aircraft, but speed also created subtle dangers. At Mach 3, a small navigational error becomes enormous. A 1-degree mistake could shift the aircraft miles off course, and because the SR-71 operated at the edge of space, pilots wore pressure suits similar to astronaut gear. If the cockpit lost pressure, survival depended on those suits. Flying the Blackbird wasn't just aviation. It was closer to controlled spaceflight. Yet for all its brilliance, the SR-71 contained a quiet paradox. It was almost unstoppable, but it was also unbelievably expensive. Each aircraft required enormous maintenance. Its titanium structure demanded specialized tools and procedures. Its engines required constant attention. Operating costs climbed into the hundreds of thousands of dollars per flight hour. And while the Blackbird outran missiles, it could not outrun a new technological revolution. Satellites. By the late 1970s and 1980 seconds, spy satellites had begun doing what the SR-71 once did, photographing enemy territory from orbit. Satellites never needed pilots. They never risked international incidents, and they never asked for aerial refueling. In a quiet twist of history, the aircraft that outran every missile on Earth slowly became obsolete, not because it failed, but because technology changed the battlefield. The SR-71 officially retired in 1998. Yet, even today, decades later, its speed record still stands. No operational air-breathing aircraft has surpassed it, which raises a strange question. Why? In an era of advanced computers, stealth technology, and new materials, you might expect something faster to exist by now. But the uncomfortable math remains the same. Mach 3 flight is brutally expensive. Heat destroys materials. Fuel consumption becomes absurd, and the strategic advantage shrinks when satellites can watch the entire planet. In other words, the Blackbird didn't disappear because it was weak. It disappeared because the world no longer needed something that extreme, but the aircraft still sits in museums today, long, black, almost alien. A reminder of a moment when two superpowers pushed engineering to the absolute edge of physics simply to see what the other side was doing, and maybe that's the strangest part of the story. The SR-71 Blackbird wasn't built to fight wars. It was built to prevent them, by watching, by knowing, by flying faster than anything else in the sky. Yet it leaves behind one lingering question. If a machine designed in the 1960s can still outrun nearly every aircraft on Earth today, what else might be flying above us now that we simply haven't been told about yet?